Welcome BSc third sem students. I am Ashok Kumar A, Department of Mathematics, GC College and Kola. We have already sent the detailed syllabus of paper 1 and paper 2 through WhatsApp group. I think you might have already noted that one. We have paper 1 and paper 2 in mathematics. Paper 1, that is the algebra and number theory, will be by Professor Apribat. I think he might have already given instruction to you. I am going to teach you paper 2, which consists of the topic algebra, real analysis and trigonometry. Now I will give you the brief introduction about the syllabus once again. First topic, that is algebra. Here we have rings, integral domain and fields. And here for this topic, 10 hours of teaching. Second topic is on real analysis. Here we are going to study the real valued functions of more than variable, that is in particular 2 and 3 variables only, limits and continuity, partial derivatives, homogeneous functions and Euler's theorem, differentiability, chain rule, total differential, Jacobians, Lagrange's mean error theorem of functions of 2 variables, Taylor's and Maclaurin theorem for 2 variables, maxima and minima of functions of 2 and 3 variables, and finally Lagrange's method of undetermined multipliers. For this, we have 20 hours of teaching. And third topic is on trigonometry. Here we have to study the expansion of sine and cosine functions, series of sines and cosines, hyperbolic functions, logarithmic of a complex number, summation of trigonometric series. Come to the first topic, rings, integral domain and fields. It is related with the group theory, which will be in paper 1. Professor Apribat will teach that. Then only I can teach rings, integral domain and fields, because it is a continuity of groups. So hence I don't teach this topic for time being. I'll start with the second topic, that is real analysis. Let me recall the function of single variable, and the extension of single variable is nothing but the 2 variable. Here you know that the function y is equal to f of x is a function of single variable. Here x is the independent variable and y is the dependent variable. Examples may be y is equal to x squared 2x plus 1, y is equal to e power x, y is equal to sin x plus cos x, say y is equal to log x, and so on. And you know how to represent the function of single variable in Cartesian coordinate system by drawing the two mutually perpendicular lines which are going to intersect at O, and we call OX as x-axis and OY as y-axis. And you know, any function can be represented in the Cartesian coordinate system. So you know, any point PAB, that means P at x is equal to A and y is equal to B, is this point, and here we represent like this. So this distance is A and this distance is B. And you have studied in detail the differentiation of function single variable. Before that we have limit, continuity and many things. Here we are studying in detail the function of 2 variables, say, which is written in the form of z is equal to f of x, y. Here x and y are independent variables and z is depending on x and y. The examples are z is equal to, the examples are z is equal to x square plus y square plus 2xy 2x plus 2y plus 1, or z is equal to say log of x plus y, z is equal to e power xy, z is equal to sin x plus sin y plus sin x into sin y, and so on. As you know, the function of single variable y is equal to f of x can be represented in the Cartesian coordinate system by joining the two mutually perpendicular lines ox and oy. But the question arises how to represent the function of two variable. Here we know that there are three variables x and y which are independent variable, and z depending upon the two variables x and y. We know that board is two dimension, but here we have three variables, it is three dimension, so it is difficult to draw the graph of function of two variable on the board. But for your convenience, I am going to give a imaginary idea. Take the three mutually perpendicular straight lines which are going to intersect at O, and I call this as OX, which is x-axis. I call this as OY, which is y-axis, and this is z-axis. Remember, these three are three mutually perpendicular straight lines, and here we have xy plane, this is yz plane, and this is xz plane. The question arises, how will you represent the point P, ABC in this system? So here we have to take a x is equal to A, take this as A and this as B. Now draw a parallelogram, and from here you have to go above, which is the distance C, and it is in the space, but for our convenience we take this point P, A, B, C. P, A, B, C. So as you know, you can make an imagery, but it is not the correct representation. As I already told you, board is two dimension having length and breadth only, but here we have the height also. So the best example is you are sitting in a room or you are sitting in a classroom, just the corner of your room is the good example for the representation of function of two variables. Now here consider a function of two variable z is equal to f of xy. We are going to study the definition of limit and continuity of the function of two variable. I think you've already studied the famous epsilon delta definition of limit and continuity of functions of single variable. Same is extended here. The definition of limit is like this. Definition of limit of function of two variable is like this. A real number L, a real number L is called limit of f of xy as x goes to a comma y goes to b, or maybe written like this: xy goes to ab. They are one and same if for a given epsilon greater than 0 there exists a value delta greater than 0 such that modulus of f of xy minus L is less than epsilon whenever modulus of x minus a less than delta, modulus of y minus b is also less than delta. And may write this as limit xy goes to AB, f of x y is equal to L. Note that L must be finite, or this also be written as limit x goes to A, y goes to B, f of x y is equal to L. Now let me give the definition of continuity. This is the definition of continuity of function of two variables. A function f of xy, a function f of xy is said to be continuous, is said to be continuous at AB, that is at x is equal to A and y is equal to B, if limit xy goes to AB, f of xy is equal to f of AB, or may also be written as if limit x goes to A, y goes to B, f of xy is equal to f of AB.